Hello guys, our lesson for today is center of symmetry. In this lesson, we will define the center of symmetry, learn how to identify it in geometric figures and use logical reasoning to prove its existence. What do we mean by center of symmetry of a curve? Now let f be a function defined over an interval I subset in R, and C is its representative curve in an orthonormal system. We call the point H, AB center of symmetry if for every x in I, one of these two are satisfied. They are the same, so either you verify that f of 2a minus x plus f of x is equal to 2b, or f of a minus x plus f of a plus x over 2 is equal to b. What do these equations mean? These two equations mean that the 2 points are equally spaced to the left and right of point A and have y values that average to b. To understand it more, let's look at the figure. Think of the point 1, negative 2 as the pivot point of the entire curve. What do we mean? If we take the whole curve and rotate it 180 degrees around the point 1 minus 2, the left side will overlap perfectly to the right side. So this side will be up and this side will be down. So how do we check whether 1 minus 2 is a center of symmetry of the curve? You simply test the formula. If f of 1 here is a, 1 minus x plus f of 1 plus x over 2 is equal to b, or this is equal to 2b, then if this is true for all x in the domain, the curve has point of symmetry about 1, negative 2. Now, for every x belongs to I, for every x in I, the domain of f, the 2 points a minus x and a plus x are equally distant from A to the left and to the right. So to make things more clear, let's take an example. Let's take x equal to 1. A here is 1, b here is negative 2. X equal 1 belongs to the domain of f. So a minus x is 1 minus 1 is 0. A plus x is 1 plus 1 is 2. Look at the graph. This is a minus x, 0. This is a plus x, 2. And they are really equally distant from a, which is 1, to the left and to the right. Now, f of a minus x is negative 3. F of a plus x, here you go, is negative 1. Now, let's add them. Let's find their average and see if it will be equal to b. F of a minus x plus f of a plus x over 2 is equal to negative 3 plus negative 1 over 2, which is negative 2, which is equal to b. So this equation should be satisfied not only for x equal 1, but for every x in the domain I. So you can say that the point 1, negative 2 is the center of symmetry of this curve. So in order to check whether the point AB is a center of symmetry, you have to test the formula f of a minus x plus f of a plus x and make sure that it is equal to 2b. If this is true for all x in the domain, then the curve has a point of symmetry a, b. We will take another example. Let's find the center of symmetry for the cubic function x minus 2 cubed minus 5. In general, a cubic function in the form x minus a cubed plus b has ab as its center of symmetry. Okay, what if the function is not given in this form and it is a cubic function? You need to change it to this form and then guess the center of symmetry. Now your guess here is that 2 minus 5 is the center of symmetry of the function. So let's verify it. How will you verify that 2 minus 5 is the center of symmetry? You verify it using the equation. So you need to verify that the function satisfies f of a minus x plus f of a plus x equals to 2b, or in other words, as we worked before, you need to verify that the 2 points that have equal distances or are equally distant from A, okay, their y values average to B. So f of a minus x and a plus x are 2 points that are equally distant from A, so their y values should average to B. Let's check that. A here is 2 and B is negative 5. So f of 2 minus x is equal, let's calculate it, 2 minus x, you replace x by 2 minus x, minus 2 cubed minus 5, 2 with minus 2, so you will have negative x cubed, which is minus x cubed minus 5, and this is f of 2 minus x. You compute f of 2 plus x by the same way. You replace x by 2 plus x, so 2 plus x minus 2 cubed minus 5, 2 with minus 2, you will get x cubed minus 5. Now add them up. Minus x cubed minus 5 plus x cubed minus 5 is equal to negative 10. But b here is negative 5. So negative 10 is 2b. And then the symmetry condition is satisfied. And the function has 2, negative 5 as its center of symmetry. Now let's talk about the axis of symmetry. The axis of symmetry of a curve C is a vertical line that divides a curve into two mirror images. What do we mean by this? Let's take 2 points. This is the axis of symmetry, x equal a, of the given figure. Let's take 2 points that are having the same distance from A. So this is a minus x and this is a plus x. If you look at their y values, you can see that they have the same y value. They are on the same height. In this case, we call x equals a an axis of symmetry. So, what is an axis of symmetry? For a function f defined over an interval I, subset in R, for every x in I, if for every x in I, the 2 points a minus x and a plus x that are equally distant from A, you will have f of A minus x equals to f of A plus x. So the straight line of equation x equal A is the axis of symmetry of C. If for every x in I we have f of A minus x equals to f of A plus x, or f of 2A minus x equals to f of x2. So if you want to check that x equal A is an axis of symmetry, you just need to verify one out. Let's look at a very clear example of symmetry. Now consider the function f of x is x minus a squared. This function, it's a parabola whose vertex is a0. Now because the expression uses x minus a, the graph is centered around the vertical line x equals to a. X equals to a is the line of symmetry of the curve. Now how do we verify this? Now reflect it across the axis by looking at the point 2a minus x. You should have f of 2a minus x equals to f of x. F of 2a minus x is, instead of x, you replace 2a minus x. So f of 2a minus x becomes 2a minus x minus a. 2a minus a is a, so it is a minus x squared. You know the square of a number is equal to the square of its opposite. So a minus x squared is equal to x minus a squared, which is f of x. So the two values are equal. F of 2a minus x is equal to f of x. What does this mean? It means that the heights of the curve on both sides of the line x equals a are the same. So the graph folds perfectly along the line x equals a. That is why x equals a is the axis of symmetry for the function.